Hello students, in this session
Let us solve a question on principal stresses. The state of stress at a point is given as that normal stresses and sum of the shear stresses in xz and zx plane and yz and zy plane are all equal to 0, and tau xy and tau yx are 50 megapascal. It means this is a pure shear condition. We have to find the maximum normal stress at a point, right? So normal stresses are 0, sigma x, sigma y, sigma z all are 0. Also the tau xz, tau zx, because the shear stresses are complementary, so xz is 0, it means zx is 0. Tau yz and tau zy is 0. Only pure shear condition is there that xy equal to yx is equal to 50 megapascal. This is given to us. Only this much condition is given to us, right? That the shear stress is given to us, and that is the pure shear condition. So this is the pure shear condition. This is given to us, right? And we have to find out the maximum normal stress, right? So let us solve this question now.
what is given in this question? That state of stress at a point is given as all normal stresses are 0. Sigma x 0, sigma y 0, sigma z 0. No normal stress is applied. Also, the shear stress in xz and yz direction is 0. But only available is tau xy and tau yx. The shear stress in xy and yx direction, that is given because the shear stresses are complementary, so xy must be equal to yx, and that is given that 50 megapascal. And we have to find out the normal stress at any angle to this point, right? The stress element, right? So what type of condition is there? It means it is a pure shear question, right? It means that, let us solve this question. The shear stress condition is like this. Pure shear condition is there. Only pure shear is applied here. This is tau yx, this is tau xy, and because these are complementary, it should be equal. So this is equal to, that is 50 megapascal. And we have to find out the maximum normal stress in the element, right? So how to find out? You know that you have already studied in principal stress chapter. Go to principal stress chapter, that when there is only pure shear, the normal stress, maximum normal stress is equal to the shear stress, right? This you should know. This always be remembered, that tau max will be equal to the tau xy or tau yx. This is the direct answer, basically 50 megapascal. So this is the direct answer. We should remember this fact, right? Also we can see it through Mohr circle, right? So if we draw the Mohr circle for this, you know, for pure shear we have already drawn the Mohr circle. Sigma n normal stresses are taken on x axis, and tau xy is taken on y axis. And if I draw it, so at the given stress element there is no normal stress. That's why the normal stress condition is 0, because sigma x is 0, sigma y is 0. So it will be origin. So it will be start from origin. And what is the circle? What is the radius of that circle? If I draw the Mohr circle, what will be the radius of that Mohr circle? So radius of the Mohr circle is given by, that is equal to, under the root, you should remember this, sigma x minus sigma y by 2. You have to go to principal stress chapter for this, and tau xy whole square, right? So here sigma x is 0, sigma y be 0, tau xy. So radius of the circle will be equal to nothing but the shear stress, applied shear stress, right? So draw the radius of the circle to a suitable scale, with scale tau x, radius equivalent to 50 megapascal, right? So when you draw it and open an compass, you will get a circle like this, at which this value, shear stress value, is tau xy or yx. This is 50 megapascal, right? Here also it is 50 megapascal. Now it will be minus minus, because it is in negative, it is positive direction, it is negative direction. One is minus, one is plus. That is immaterial. Magnitude is 50 megapascal, right? Now how to find out normal stress using this circle? So normal stress lies on this axis, right? and we have to find out the maximum value. So maximum value is the periphery of the circle. So periphery of the circle cuts the x-axis here only, and also periphery of the circle cuts here only. So normal stress will be maximum, that is 50, because the radius of the circle is at the outer radius. We get the from origin to this will be a 50 megapascal distance, right? So this is nothing but the 50 megapascal. So that's why sigma max is 50 megapascal. Or here sigma max is if I see sigma minimum, if you want to find out sigma minimum, that is equal to negative of this, that is minus 50 megapascal, right? So that's why you can see that for a pure shear element, this is a pure shear. So for pure shear element, the center of the circle passes through the origin, and the maximum stress is equal to the shear stress applied, that is 50 megapascal. This is 50, this is 50, this is 50, this is 50, right? So shear stress and maximum normal stress will be equal, that is 50 megapascal.